Hello, everyone. Thank you for joining us. Today, Men&Mice and NS1 join forces to tell you how to reach ultimate network resilience with xDNS redundancy. This webinar is focused on how to ensure high availability by maintaining DNS redundancy across multiple DNS service platforms, on-premises and in the cloud. My name is Dagmar. I'm the marketing director here at Men&Mice, and I will be your facilitator today. And with me are Sigfus Magnusson. He's the VP of Product Management here at Men&Mice, and James McCarthy. He's the Director of Solutions Engineering at NS1, and they will cover the webinar topics today. We will be taking questions during the webinar, so I encourage you to submit questions in the questions functionality of the GoToWebinar, and they will be answered at the end. Please note that all attendees are on mute and that we are recording the session. So you'll find the webinar along with the slides on both Men&Mice's and NS1 websites in the next coming days, as well as having it emailed your way. So without any further ado, I think I'll just hand this over to the boys. So let me see. Sigfus, will you take over?
Yes, thank you, Dagmar. Just if you could.
Let me see.
I'm gonna start sharing my screen here. And hopefully you can see my screen now. Wow, so flicker. Okay, so welcome to this webinar, everyone. This is the agenda for today. We're going to talk a bit about Men&Mice because we have a lot of attendees who are not familiar with Men&Mice, both the company and our products. Then we're going to talk about the importance of DNS redundancy and how we get there from 1987 when DNS was sort of invented. Then we talk about the cloud-based DNS services, and James is going to pitch in there with information about NS1, the company and its products. Then we move on to the challenges of DNS redundancy. Most companies want to accomplish this, but it may be challenging to configure and maintain DNS redundancy. And then we move on to the xDNS functionality and our demo of the product. So first, Men&Mice. We started in, actually the company is founded in 1990, and in 95, we wrote our own DNS server. So at the time, it only a few DNS servers out there, and we felt it needed a more diversity. So we decided to write our own DNS server. We actually then, after a few years, we started to manage also other DNS servers like Bind and Microsoft DNS. And today, we have a fully fledged DDI solution, DNS, DHCP, and IPAM for a variety of DNS servers and DHCP. Men&Mice is a very strong overlay solution, so which means that you have traditionally like a DNS and DHCP servers, a company has all these servers, and instead of replacing your DNS or DHCP servers with something else, or you can then just put Men&Mice on top of the servers and manage them through Men&Mice. It supports also some cloud-based DNS services, as you can see in the next slide. So companies with a very complex environment with multiple DNS servers, like hundreds of DNS servers or hundreds of DHCP servers, can use Men&Mice to manage the whole thing with an intuitive UI. It has really powerful APIs, so which means that you can build automation on top of your DNS and DHCP servers. It also has unparalleled support for Active Directory, so both the users and groups authentication, you can specify which users can do what in your environment through Men&Mice, and also we integrate with Active Directory site and subnets as an example. If you move your data into the cloud, you build networks in the cloud and instances in some cloud platforms, you can manage them and see them through Men&Mice. And like I mentioned previously, it's an enterprise scale solution that supports hundreds or thousands of servers and millions of IPs. Here is an architecture diagram of Men&Mice. So Men&Mice in the middle here, you can deploy Men&Mice in a high availability mode, which means that you don't have a single point of failure. You can manage your networks in AWS and Azure. And through xDNS, you can manage your DNS data on NS1, Line, Route 53, and Azure DNS. On the inside, you have Microsoft Active Directory, you have DNS and DHCP, You have support for Power DNS, Unbound, and Bind, and IAC, DHCP, and CARE on the Unix platforms. And then we synchronize with Cisco, DHCP, and routers and switches in Active Directory. Now, as most of you hopefully know, DNS is really critical. It is a service which is under a constant threat, especially external DNS. So we have DDoS attacks constantly hitting your DNS servers and trying to exploit vulnerabilities. Now, bad DNS performance may drive customers away. So if your customers are trying to reach your website, as an example, and the DNS performance is bad, they might just go away and just try another site since they don't have the patience to wait for a result. But at the same time, no DNS will drive customers away. So it will, if the customers can't get to your site, obviously they will move away. Uptime is mission critical. I mean, every minute you're down is costing revenue. So how do you address that? You address that through DNS with redundancy. And traditionally, companies have been using the master-slave format. So I have one master server and few slaves, which provides DNS redundancy. But this has its drawbacks. So with master and slave, we have only one server who has a writable source, and you can only make changes on the master server. And the slaves will pick up the changes through zone transfers. If the master server goes down, then the slaves are allowed to hold the zone for a specific amount of time. And after that time, they will drop the zone. So if the master server isn't brought up again, or a slave server is promoted to be a master, then the zone will be dropped after a specific amount of time. And this is something that we've seen with our customers. So they have maybe one master server and a few slaves, maybe 4 or 5 slave servers. The master server is not available, and they think it's only stopping them from making changes in DNS, but that's not true, because they don't reinstate the master server, then the slaves will drop the zone after this period of time. It's also pretty tedious to promote a slave to become a temporary master server. So there's a manual intervention. And also this is a really homogeneous environment. Usually it's running on Bind or some the same DNS servers used for both the masters and the slaves. Companies have tried to make this more secure by taking the master server and making it a hidden master server. So it's not being constantly hit by DNS queries from the internet. But that's not enough, because if, for example, the server fails, then you can't make changes to it, and the same applies to as before. Now, companies, they solve this or address this by implementing multi-master setup. So they might have a few bind servers, and instead of having one master server and a few slave servers, they will all be master servers. Then you have to make sure that they synchronize changes between them. Either you make changes on all the servers, or you make changes in a central server and have it somehow distributed to the other servers. So you would write your own replication system. So you can't rely on the master-slave, the zone transfers. You would have to write some replication between the servers. And usually when you write something like that in-house, you test the happy path. So basically, if everything is working fine, then the script runs fine. But if something happens, then the servers might get out of sync. And the same way with the previous setup, the master-slave setup, you have a very homogeneous environment. All the servers are the same, and if there is a vulnerability in this case Bind, it would affect all your DNS servers. So what we see our companies doing is taking the critical zones and placing them or storing them or hosting them with external cloud-based DNS services like NS1. So these are like teams of people who are just dedicated into making sure that your DNS is always available. They are experts in their field, and instead of you being patching your DNS server, making sure that Bind is always up to date, or your external DNS server is always up to date, and monitoring attacks, you just leave this to these companies to make sure that your zones are reliable, available. They provide scalability and performance, and also security. So, James, over to you.
Good afternoon, Sigvus. Nice to be with you again. Good morning to our American listeners. So NS1 was started in 2013 by a small team of infrastructure experts who had previously built CDNs and cloud platforms and metal as a service, and all sorts of infrastructure products. And during that time, they saw a need for a more a DNS provider that allowed them to make intelligent traffic management decisions, and decided to start NS1. So I think what makes NS1 unique is this kind of combination of filter chains and data, and we can ingest data from different sources, from the customer's own data feeds, or from third party, or even using our own. And that allows our customers to have real control over the records that returned in real time. And as you can see, we're trusted by some of the biggest sites on the internet, and some I can name on our slide, and unfortunately some we can't, but a good cross section of the websites and applications you may have heard of. So I think one of the important parts of being an Anycast DNS provider, a managed DNS or cloud DNS provider in this environment, is to have an Anycast network that is globally dispersed, and we have a 24-POP network, which is spread across all the inhabited continents of the world. Not just obviously a good coverage you can see in North America and Europe and across Asia, but also pops down in Brazil and South Africa and Australia as well. So overall good low latency across the globe, and and our kind of design philosophy of our network is to build it stable and build it strong. So we have a lot of tier 1 providers and a lot of smaller regional providers, and all to give a good mix of connectivity and a kind of oversubscribed in that regard. So we have much more capacity than we need for day-to-day DNS, but that's because of the kind of threat we're talking about today. So so overall built for resiliency. So the DNS attack landscape, as we've been talking about, has changed. You can see on the right there, this is just a general graph of reported DDoS attacks over the last few years, and you can see the trend is up and to the right. That's something that all types of infrastructure as a service providers see, but certainly a trend we also see in the DNS landscape. So 2016 was especially a relevant year for that, and we saw an increasing complexity, an increasing scale, with lots of new Internet of Things botnets brought online, as I'm sure a lot of people are aware. So I think moving on to the next slide, we're going to talk a little bit more about that. Are we, Sigfus?
Yes. So what I'm going to actually talk about now, or we, is we have companies like our customers moving to cloud-based DNS solutions, and for a good reason, which we talked about previously, the scalability, reliability, and all these good things. But these providers are still being hit by a lot of attacks, like James mentioned. And one of the attacks was really public in October last year, when Dyne was pretty much brought down. And that raised a concern with some of our customers, and actually just companies out there. So any system, how resilient it is, it can be brought down if you have just a massive attack on these DNS servers. And the Dyne was basically brought down, and your DNS zones were not available. So you had moved your critical zones to Dyne, and to make sure it was always available, and now it actually all of a sudden wasn't available.
I think it's worth. Sorry, Sigfus, I was going to say, obviously, the important thing to note is, the the complexity of DDoS attacks affected lots of different providers. So, it's not just dying in the DNS landscape, but certainly, that brought it to the attention of a lot of people because it was such big headline news. So, certainly we've seen a lot of our customers adopt dual provider strategies because of, or multi-provider strategies because of, those issues that occurred.
Yeah. Excellent point, James. Yeah, I mean, it's not only Dyn obviously hit, but this was really public attack, and also made sure that triggered the interest in multi-provider DNS. And then you took your DNS, you placed it with multiple providers, maybe with NS1, maybe on your local bind server, maybe with Azure DNS or someone else. And that posed a new problem. So you need to make a change to your external DNS. How are you going to make a change across all these different providers? And how are you going to do that if one of the providers is not available? So you need to add a new record, you need to change the record. And now one of the consoles is not available. So you have to make note of this change, which you're able to only to apply on one of the platforms. And then you need to do another change and another change. You have to make sure you do it on all these different consoles, while some of them might be available and some not. Then you come to a decision. Maybe you write a script, or you use an open source tool to keep them in sync. But for an enterprise, that also is a bit of a risky business. For example, who maintains the scripts? You can write them in-house and then rely on your in-house talents, and they won't move away. Also, how reliable are these scripts? And we saw when this attack occurred, we saw a need for an enterprise-grade DNS redundancy solution. So instead of writing our own DNS server like we did back in the days, we decided to write a system within our DDI platform that would provide DNS redundancy for our customers, meaning that they can take any zones, any master zone from all the supported platforms, and group them together into like one entity within the system. So xDNS eventually will eliminate this single point of failure. If one of your providers, you place a zone with 2 or more providers, if one of them is having issues, it won't affect your ability to make changes. Maybe you build automation on top of your DNS, and you can do it through Men&Mice then, which will then create and delete DNS records according to your script. And if one of the providers is not available while a change is being made, you will make sure that the change is applied when it becomes available again. And changes made externally to DNS zones will be replicated to other instances. And this is the true overlay nature of Men&Mice. The same applies to, for example, if you're managing a Microsoft DNS server, a standalone Microsoft DNS server, and you make a new DNS record on the server, it will be visible in our UI, and you can see it and make changes to it and so on and so forth. The same applies to xDNS. If a change is made to an external in a console, like the native NS1 console, you create a new DNS record there. It will be visible in Men&Mice, and we will make sure it's replicated to the other members of the group. So now I'm going to switch to a demo. And to save time, I did a recording of the demo. So here it goes. I'm going to log into Men&Mice as an admin through the Men&Mice management console. And once we log in, we can see the DNS servers that we are managing through Men&Mice, through this instance of Men&Mice. So as you can see, I have a few DNS servers, 7 in total. I have a Route 53 DNS server, Azure DNS. I have a Dyn server, a couple of bind servers, and a couple of Windows servers. So this represents both external and internal DNS within the organization. If I click on a particular DNS server, I can see the zones on this server, and I can manage them freely. I can create new zones and make changes to the zones. And the same applies to whether it's an external, like a cloud-based DNS or an internal DNS. It really doesn't matter. The same UI to the user. Now, if I go and click on the DNS zones, I can see the DNS zones across all my DNS servers. So for an end user, he doesn't really know or need to know where the zone is stored. He just needs to make a change to a zone. He goes into the list and opens a zone and makes a new DNS record. But we're going to focus on NS1 in this demo. So I'm going to add my NS1 account here. And for that, we just need a name for the account, and then an API key provided by from my account. Now, when we add the account to Men&Mice, Men&Mice will connect to the account and pulls in all the DNS entries from my NS1 account, so nothing more is needed. I click on the account and I can see my zones, and I can start to manage them. It's really simple. Now, so let's just close the zone and move forward with the with my demo here. In this case, the company has a critical DNS zone, so a mission critical zone, and MM-Demo.net, it's been maintained and managed through Men&Mice for years. So if I open up the zone, we can see the records, and if I look at the history for the zone, we can see there's a lot of history of changes that have been done through Men&Mice to the zone, dating back to 2014. Now we can just close these windows here, and we can migrate the zone with the history to NS1. As simple as before, we just go into the wizard, select the destination DNS server to migrate the zone to. We can delete the original zone, but I'm not going to do that. Enter some save comments into a save comment dialog box. And then we just hit next and then finish. So this is going to take the zone and create an identical copy of the zone on NS1. So it's going to be identical to the one which is on my bind server. Takes a couple of minutes, and now the zone has been created on the NS1 server. Now, take note of the DNS entries. So it will be automatically generated by NS1. So when we create a new zone at NS1, we get just handed out some DNS servers. And in this case, we're just going to test whether the zone has been correctly created on the NS1 servers. And we can see that www returns back with .7. Now we're moving back into the console. So what we have now is my critical zone is now on these two providers, but I'm going to create an xDNS group for my zone. So I give it the group a name, and in this case, critical zones, and it's going to be on these two DNS servers. Now, in the next slide here, we can, or the next panel, we can see or choose which instance is the initial zone to synchronize. So if the zones have a discrepancy, you can fix them in a later panel. But since I just migrated the zone from one source to another, they are identical. So I can just choose either one as the initial synchronization zone. Go into the next panel, type in some save comments. And this is what the Men&Mice is now about to do. It's going to create a redundancy group of these two zones. So now this has been done, and we can see that if I click on my xDNS zones filter, I can see that MM-Demo.net has been created, and there is a redundant group now with these two zones. So just to demonstrate how we apply changes to both instances, I'm just going to run a dig command on the DNS server. You can see that they have the same results. My NS1 and my appliance or my bind server have give the same results for www. And now I'm going to write a short, like a one-liner here that will repeatedly query the DNS server for www and do it on both servers. Okay, so I'm done here. And we can see that they both return 7, and still everything is good. So when I make a change to the zone, either through our console or through the API, it's going to be applied on both servers. So now I'm just going to create change 7 to 8, save, and we see here in the save comment dialog box what changes it's about to do. Hit OK, and then go back into and see that the results have been applied on both servers. So any questions from the audience? Dagmar.
Hi there, hold on. Let's open up here the questions panel. Let's see. Okay, here we have a question. It says, what about external changes? If they, for example, conflict, will they still be created?
Okay, yeah. So like I mentioned, that external changes are replicated. So if you are hosting your zone with NS1 and Azure DNS and you make a change through the NS1 console, we'll make sure that the change is replicated over to the other system. But if you make a change outside of Men&Mice and it's a conflicting change, so you make a change on NS1 and also on Azure through the consoles, and these are conflicting changes, like a 1A record on one of them and a CNAME on the other, then we will make note of this in our health bar in Men&Mice and allow these discrepancy to exist on the two servers. So we won't create like a conflicting data on the servers, or make sure, for example, if this would be applied then on a bind server, it would refuse to load the zone. Okay.
Okay, we have another question here. Is it possible to enable xDNS redundancy for dynamic DNS zones?
Yes, for dynamic DNS zones, we can do that. The only zones which are left out of the matrix are the AD zones, which are typically internal to the company, and they are replicated to Active Directory. So they have been left out of the matrix of zones that can be replicated or can be added to xDNS, but dynamic zones can definitely be added.
Okay, we have here, can zones from any of the supported DNS servers be in an xDNS group?
Yes, well, we actually do support also caching only DNS servers, so which don't have any authoritative zones. So with the exception of Unbound, you can take data and zones from all the supported platforms and create an xDNS group from them. And maybe I can also mention that these don't necessarily have to be the same zones. So you can actually take Men&Mice.com, Men&Mice.is, Men&Mice.net, and create an xDNS group for all these zones, which would then be maintained as one.
Okay, excellent. At this moment, there aren't any other questions in the question panel of the GoToWebinar. Of course, attendees can always send us an email to info@men&mice.com if they have any questions that awake or that we will definitely answer and get back to you on. Is there any other input from you, James or Sigfús, before we then end the webinar?
Yes, thank you. I just wanted to make one last point about Sigfús's demo about the replication you could see happening in near real time as he's making the change. That change is replicated across our global network within under a second. So I think that's important to note that between Men&Mice's application, overlay, and our network, those changes are going to replicate across all your services very, very quickly.
Yeah, excellent point. Yeah, so well, either you write or make a change through a script in Men&Mice or through our UI, and it's global instantaneously almost to the change. So Dagmar, I don't have any further comments.
Okay, so I think we are at least like 15 minutes ahead of schedule, which is good. But I think that we will then end this today, and I just want to thank everybody for joining us, and I really hope that you enjoyed the webinar. Again, we will email you the recording and slides, as well as list this on both NS1 and Men&Mice's website, and hope that you will be joining us at our future webinars. So I'll just say thank you for today, guys. And
thank you very much.
Thank you. Bye-bye.
Bye.
Bye.